Oh no, hey, I wrote that wrong. I was, never mind. It's not grilled sandwich day. What kind of idiot wrote that? I'll have a panini, please, to celebrate. No. Yeah, sometimes I'm not quite awake when I get here. It is National Grilled Cheese Day. Grilled cheese sandwich. And I don't have room to write sandwich, so I won't even write it. But if most people say grilled cheese, they know it's a sandwich, right? It's not like you just took a piece of cheddar and threw it on the grill and just let it melt through the grate, right? There's some grilled cheese. Happy Thursday. Okay. Stylus, there we are. All right, ready? We're going to prove the last two. We're going to extract any kernels of wisdom we can from it. And a lot of people were here this morning toiling, laboring, and made some progress, right? You created furrows in the mind. That'll never go away. That's good. Right? What's that? Sometimes it's good. Sometimes if you walk away from something, your subconscious will continue to work on it, and then inspiration will come to you after it's kind of simmered for a while and reduced down. That's exactly how Kekule came up with the configuration for the benzene ring. Yeah. Okay. So sine plus cosine times tangent plus cotangent equals secant plus cosecant. True. Okay. Right? Yeah, done. Right, done. Done. All right. So I gave you a true or false test and they're all identities. That would be good. Okay. All right. On which side would you want to start? I would say the left. Yeah. Just because it has more stuff. Okay. But the right side is plausible as well because it has two terms, and we can get non-trivial denominators and get a common denominator so that we can have a single term, which is really what we have on the left. We have a single term with two factors. In the factors, we have double terms. Okay, so if we did start on the left, what would you do? Would you call this 1? No, that would be a grave error, right? That's not Papa Pid. Would you expand? Would you distribute? I would maybe distribute, okay, because notice you have two terms on this side. It's essentially expanded, and it's factored on the left. So this would fall under the guise of doing some obvious math. So let's go ahead and FOIL it out, right? First outer inner last, sine times tangent. And remember to include your x's. So if you forget them, go back and put them. So that's sine times tangent, and then plus sine times cotangent, sine x times cotangent x, plus cosine of x times tangent of x, plus, I have to remodel. Remodeling used to be hard with paper and pencil. It's real easy with Notability. Plus cosine times cotangent. And now you're like, wow, whatever that is. Okay, sweet. What next? Do we have any like terms? Does anything cancel? Please say yes. Yes, okay, good. What cancels? Nothing. Shoot. But at least y'all said yes. There you go. I'm not sure if things divide out or whatever simplify. So putting things in terms of sine and cosine could help you decide that. So let's do that. So this becomes sine of x, I'll say over 1, times sine x over cosine of x. Plus, this is sine of x. I'm going to choose to put it over 1 just because it looks like a fraction now. And cotangent is cosine x over sine of x. That's going to make me happy. Do you see? See what's going to happen there on the next line? Not on this line, but on the next line. Okay, plus cosine of x over 1 times tangent, which is sine of x over cosine of x. Again, I'm getting happy again. Plus cosine of x over 1 times cosine x over sine of x. Okay, all right. So why was I getting excited? Because now, and if we take inventory, let's see, we've got, how about sine times sine? That's sine squared. All over 1 times cosine is cosine. Plus, we're left with the cosine here. Plus, we're left with the sine there. And then plus cosine squared of x over sine of x. All right, compare that to the right side, and you're like, hey, what? Hey, can we call that 1? Can we call sine squared plus cosine squared 1? You're right. Not in this case, because that's not sine squared plus cosine squared. If they were both over the same denominator, could we? Then we could, because then we can essentially combine them in the same term. But they have different denominators, so I can't quite do that. So don't make that a careless mistake. So at this point, maybe you're not sure how to get them together. You could get a common denominator across the board, but maybe at this point, because you have 4 terms and it's already in terms of sine and cosine and you get stuck, what did we learn yesterday? It's okay. It's not admitting defeat to go to the other side. Go to the other side. Not go to the other problem, go to the other side. All right, so let's put it in terms of sine and cosine. Secant is 1 over cosine, and cosecant is 1 over sine. And now I'm like, oh, that's so much better. That looks a lot more like the left side. Sure. Okay. Help. How? So I can replace this with 1 minus cosine squared? How would that help?
Then in the next step after I do cosine of x underneath that, secant of x times 1 minus cosine squared of x.
So you did secant times 1 minus cosine squared? And then you distribute, and did that lead anywhere? It did? Oh, sweet. Okay. All right. All right. So, I mean, we got to find something to do, right? So he said he called sine squared 1 minus cosine squared. And then 1 over cosine, he called secant. So you could do that in the same line. I'm okay with that. And then we have plus cosine of x. And this is really just kind of going further away in the hopes that it'll come back. Did you do the same thing with this? Okay. So you called cosine squared 1 minus sine squared. And again, parentheses are super important. I see some of y'all's work, and it's not happening, so they can mess up. You can kind of expect that this one's going to be a little bit more involved because it's the second from the last one. All right, now you distributed, okay? So if you distribute, you get secant minus secant times cosine squared. Now that's going to be interesting. I'm going to go ahead and say that that secant times cosine squared, I'm going to say is cosine of x times another cosine of x, like that, plus the cosine of x, plus the sine of x, and then similarly over here, plus cosecant of x, minus a cosecant of x times sine squared, which I'm going to write as sine of x times sine of x. And I'll show you why here in a second. Okay, so that was not a bad thing to do. That was not a bad thing to do. Notice we have to somehow use the cosine in the bottom and the sine in the bottom, because that's what we kind of came with over here. And that's how, if you didn't do the step on the right, you're trying to get to a secant and a cosecant. So what Mr. Bird suggested did allow us to introduce a secant and a cosecant into the fold. So that, in hindsight, is not a bad thing to do. Now, what happens with some of this stuff? Let's see. What is secant times cosine? How are secant and cosine related? They are reciprocal. So if you want to take another line and call either secant 1 over cosine or cosine 1 over secant, that's fine. But it happens enough that you might want to just try to start recognizing secant times cosine is 1, cosecant times sine is 1, and tangent times cotangent is 1. So we can call this then secant of x minus, because that's a 1, essentially. Don't write it there. You just get a cosine plus the cosine plus the sine. And then similarly over here, we get plus a cosecant. And then what's a cosecant times the sine? A 1. So we get minus sine of x. And I think now, like unstacking the speed stacks, it's going to come together real fast. Those do what? Cancel. Good. Those cancel. That's where you say cancel. And we're left with secant of x plus cosecant of x. And is that the same now as the right side? Oh, it's not. So you either now on the left side call it 1 over cosine plus 1 over sine, or you do what a cat does. It buries its stuff so you can't see it. You get rid of what you started over there. And now they look the same. Are they in the same order? Are the terms in the same order? Yes. On the left, if you happen to have cosecant plus secant, you go one more line and commute it around. Very good. Well done. Yeah. I don't think that's necessarily what I did in the past, but that works great. I like that. Okay? That's certainly not the only way to do it. What you could have done, which was another option, was you could have gotten a common denominator all the way across and a common denominator all the way across. Let's see how that would have looked, shall we? It's kind of nice to see it done a different way. I like that. That's pretty nifty. So I'm just going to cut that, and we'll put it over here. And we'll space bag it and put it under the bed. Just like, okay, cool. There we go. Well, it's there if we need it. All right, so here is where we were before. Just another, we were at a fork in the road, right? And as Yogi Berra said, not Yogi Bear, he said, boo-boo. Yogi Berra said, when you get to a fork in the road, take it. Take it, right? And maybe it'll complete your silverware set. Yeah. All right, so let's go ahead and get a common denominator. What's the common denominator going to be? Louder? Cosine times sine, right? We have a denominator of cosine, a denominator of sine. So if I multiply this one times sine over sine, I get sine cubed. Good morning, thank you. I get sine cubed all over sine of x cosine of x. Plus, if I multiply this one by sine cosine, I get sine of x cosine squared of x all over sine cosine. Plus, if I multiply this one by sine cosine, I get sine squared cosine all over sine x cosine x. And this one has the sine, so it just needs a cosine, so I get cosine cubed of x all over sine of x cosine x. So you see what I did there? I just multiplied every term by a clever form of 1 to make sure it had the sine x cosine x. All right, so now what would be the benefit of that? Very good question. I've got a sine cubed of x plus a cosine cubed of x plus, those aren't like terms, sine squared cosine. I rewrote these, plus sine squared cosine. And all of that now is over sine x cosine x. I forgot my x, so I'll come back and add it. Everything looks good. All right. Now I'm going to do the same thing on the right-hand side. So cosine sine is still the common denominator. And the first one has the cosine, so I multiply by sine over sine, so I get sine of x. This one has the sine, so I multiply by cosine over cosine, and I get cosine of x. And now what? The denominator is the same. It just flipped around. So really all I have to do now in this version of the proof is to show that my numerator is equal to sine plus cosine.
You need to start doing that. Technology, if we have a technology specialist, we need to report to the 600. Technology report to the 600. Thank you.
I'm sorry. Example 10. Prove the following identity. That's the instructions. Forgot to read them. Yeah, that was directed at me. I felt it. I felt it. Ugh. Just like that email. Okay, all right. Sweet. What do we do from here? What do we do? Yeah. What you got? What? This is going to be hard to salvage from here, right? It's going to be hard to salvage. You do have a sum of 2 cubes, and that factors into something, doesn't it? Let's kind of review that. It might be useful. If you have, here's our space bag. Hi, space bag. What are we doing under the bed? It's a good place to work. Nice and quiet. If you have x cubed plus y cubed, that's the same as x plus y times x squared minus xy plus y squared. That's the sum of 2 cubes. That's the formula. I don't know if you remember that from Algebra 2. And there's also one for difference of two cubes. So you can't factor difference of squares, or a sum of squares, but you can't factor a sum of cubes. If it were x cubed minus y cubed, it would be x minus y, and now it's x squared plus xy plus y squared. So maybe this is kind of what we're faced with over here, sine cube plus cosine cube. That could factor into sine of x plus cosine of x times sine squared of x minus sine x cosine x, and then plus cosine squared. And so that would be what we could factor that as. And then in the next group, plus, we have common factors. We could pull out common factors of sine cosine. Not with a highlighter, though. Let's try that. Sine x cosine x times sine x cosine x. Did I write that? Hang on. I don't even know if I wrote that correctly. I didn't. That's sine. I have an extra squared there. See, one little thing can make it. It's the other way around. Yeah, I need to erase it on the squared. Okay. Wow. I'm kind of liking Mr. Bird's version a little better. Yeah. Sine x cosine x. So that leaves me with a cosine of x squared, or just a cosine of x, sorry, plus a sine of x. All over sine x cosine x. Hang on, we're going to salvage it. This is pretty awesome. Now notice I have two terms. I have this term and this term. Is there anything common in both of them? Sine plus cosine. Yeah, buddy. So that's going to be sine x plus cosine of x when I factor it out. Beefy bracket. I'm left with this, which notice that's sine squared plus cosine squared, right? I can now call that 1. So that's 1 minus sine x cosine of x plus the sine x and y'all are getting excited now because you see it's going to work. All over sine x cosine of x. And now what happens? These cancel, and we're left with sine x plus cosine of x all over sine x cosine of x. And if you compare that to the other side, is it the same? Not quite. My denominators are different, so I would need to flip this one around because I have more space here. Sine of x, cosine of x. And there you go. We salvaged it. Okay? Done. Or how about no thanks? Right? So we salvaged it. We persisted. We kept going. We prevailed in the end. We had a patient pertinacity. And that's all you have to do. Okay, now that did require a special product here, a sum of two cubes. But I think I'm going to put this one under the bed in the space bag and bring this one back out, right? And just wear this one all winter. This was a much better version. Okay? So there you go. That's why we do it multiple ways, because all we have here are strategies. And you have to go the way you see it, right? Everyone sees things a little bit differently. Okay? Comments or questions on that one? That was fun, wasn't it? Yeah. Good life lessons. Okay. So if that was fun, we're going to conclude with the Kodiak grizzly bear. So you got bears, right? Cute. You got black bears, grizzly bears, koala bears, polar bears, teddy bears, gummy bears, yeah. And grizzly bears are supposedly the fiercest, but people who say that have never run into a polar bear in the Arctic tundra.
Grizzly bear.
No. What?
Grizzly bears across the street.
Right. The polar bears are coming south, and the grizzlies are going north, and they find each other attractive. And so you're getting hybrids. Yeah. But polar bears are pretty fierce. They look kind of cute, especially when they're drinking a bottle of Coke. But Kodiak grizzly bears are the fiercest and biggest of all grizzly bears because they grow on Kodiak Island, relatively undisturbed. And, yeah, you don't want to mess with a Kodiak grizzly bear, okay? Werner Herzog did a show called Grizzly Man. Have y'all ever seen it or heard of it? It's about a guy who thought he could live among the grizzly bears, and he filmed himself living among the grizzly bears, and they kind of liked him. But then his personal videos stopped one day because the grizzly bears got hungry, and unfortunately, both he and his girlfriend, who lived with him, became food for the grizzly bears. So yeah. It's a good show, but it's a very kind of almost predictable ending. Like, dude, why are you doing that? Just, go live in the city, get a job, and maybe put a picture of a grizzly bear on your wall. Okay? Anyway, he suffered the ultimate price. Tangent over 1 minus cotangent, and then they go out and shoot the grizzly bear that ate him, like it was the grizzly bear's fault. Plus cotangent over 1 minus tangent equals 1 plus secant cosecant. This doesn't look like a grizzly bear, right? You want to poke it with a stick? Let sleeping dogs lie, or bears, for that matter. Let's go ahead. Let's poke it with a stick. Ready? Okay. Right. Yeah. I want this one to be exciting. It's our last one. We got 20 minutes to do this one. Can we do it? No. All right. No. Okay, let's try it. Left side, yeah. Let's start on the left side. Let's get a common denominator, shall we? Let's get a common denominator. I'm going to do the crisscross applesauce trick. So that's the butterfly multiply. Start in the top left and multiply. You're going to get tangent of x minus tangent squared. Plus the middle sign, and then the other diagonal, cotangent of x when you distribute is minus cotangent squared of x. All over the product, 1 minus cotangent, 1 minus tangent. I'll go ahead and multiply that out. That's 1 on the first. When you multiply the inside, you get minus cotangent of x. On the outside, minus tangent of x. And then plus cotangent times tangent. Okay, that looks pretty good. So that's the quickest, fastest, easiest way to combine two things that don't have a common denominator. Instead of multiplying both of them by a clever form of 1, you just do your crisscross applesauce. But you got to start in the top left. Okay? So good so far? Everyone okay with that? All right, now let's see if anything happens in the bottom or the top. Hey, in the bottom, I see a couple of things happening. First of all, what is cotangent times tangent? It's 1. So that becomes a 1, and I got 1 plus 1, which is 2. Hey, let's review that. 1 plus 1 is 2. I should probably show that as a separate line, though. So that's 1 minus cotangent of x minus tangent of x plus 1. And then on the next line, I'll call that 2. In the top, I have tangent of x minus tangent squared of x plus cotangent of x minus cotangent squared of x. So that was a lot of rewriting just to call that thing 1. But I didn't see anything else that I can immediately do, right? Yeah, that's me. You could have done that from the very beginning. Absolutely. Yeah. Did you want to do that? No, you could. Absolutely, you could. I chose not to do that just because then you're going to have to start getting fractions with sines and cosines. But it would work. It would work. Now, notice, are the Pythagorean identities going to be real useful here? Can we write tangent squared in terms of cotangent squared by a Pythagorean identity? No. So I don't know if that's going to be helpful. But it might help us introduce secants and cosecants, which we do need on this side. What should we do on the right side? Let's go to the right side. This is one we're going to kind of chip away at it on both sides. Let's go ahead and write it in terms of sine and cosine over here. 1 plus 1 over cosine times 1 over sine. Okay, so now the common denominator would be cosine sine. So you can call 1 on this step cosine x over sine of x times cosine x over sine of x plus 1 over cosine x sine of x. And now on the next line, we'll combine them and we get cosine x sine of x plus 1 all over the common denominator, cosine x sine of x. All right, looking good. Not really. So yes, now if I hadn't done it in the very beginning, Brooke, I might say, you know what, I'm going to go ahead and put everything in terms of sine and cosine. What that does is it just has you work with fewer things. So, man, that's gonna be a nightmare. Would you rather get rid of all this work and go back to the top and put it in terms of sine and cosine? Or just put this in terms of sine and cosine? It's up to you. You tell me. I don't care. What would you do? That. All right. Yeah. This, would you do this or that? That. Okay. My fault. So let's just keep it going then. Sine of x over cosine of x minus sine squared of x over cosine squared of x plus cosine of x over sine of x minus cosine squared over sine squared. Yahoo! All of that over. Are you kidding me? Nope. Hey, 1 plus 1. Look at that. That's a 2. We got a 2, folks. Minus cosine x over sine of x minus sine of x over cosine of x. Is this necessarily the most elegant way to do this proof? Not necessarily. We're kind of doing it by brute force. Okay? But the good news is, now, two things. Both sides are in terms of sine and cosine. Yes. And we have one term on each side now. Yes. So those are good things, kind of. All right, so now on the left side, we've created a complex fraction. Big time complex fraction. Okay? So remember, when that happens, the next step is always to eradicate it. And you can't do state change flip. You got to do LCM over LCM. So what is the LCM of all your miniature denominators? Sine and cosine? Well, we need at least one sine and one cosine, but then we have to take the largest representative of each factor. We have a sine squared and a cosine squared. So guess what the LCM is? It's sine squared cosine squared. It has to be one of each factor, and then you take the largest representative of each factor. So it's sine squared cosine squared. Now in this line, you can do that because that's equal to what? Well, we just multiplied by. This is equal to 1. So that's legal. Okay, now it's like a distributive party. Ready? Bring who you want with you, Connor. He's fine to bring along. He could be helpful. He said God. All right. So when you distribute to the first one, one of the cosines divides out. Yes! And I'm left with sine squared times sine, which is sine cubed times just one cosine. All right, looking better already. I'm so pleased. Minus cosine squared divides out, and you're left with sine squared times sine squared, which is sine to the fourth. Plus, one of your sines divides out, and you're just left with sine times cosine cubed. Minus your sine squareds divide out, and you're left with cosine to the fourth. Super awesome, wonderful. And at the bottom, I distribute, and I get 2 sine squared of x cosine squared of x. Minus one of the sines divides out, so we're left with sine of x cosine cubed. Minus one of the cosines divides out, so you're left with sine cubed cosine of x. Sweet, wonderful. And now the left side's really starting to look like the right side. I forgot an x right here, sine cubed of x. All right, good. Oh, that makes a difference. Hey, do these divide out? No, those are terms. Okay, great. Do we have any common factors in the top and or bottom? In the top, we don't have a common factor. But in the bottom, it looks like we do. But it's the one we just distributed. Kind of, almost, not really. Let's try it. What's common in the denominator? They all have at least one sine and one cosine. Or, look on the right side, a cosine sine. Are you with me, Serge? Let's try it. Cosine x, sine of x. Parentheses. When you factor that out of the first term, you're left with a 2. You're left with a sine. Maybe the sign is stop, run away. 2 sine x cosine x. Okay, minus, when you factor it out of the next one, you get rid of the sine and you only have cosine squared left. And in the third one, you get rid of the cosine and you're only left with the sine squared. And in the top, I don't really see what I'm doing in the top. So I'm just going to copy that and paste that. Okay, thank goodness for notability. Okay, now, notice we are almost there, right? Yeah, they got cosine x, sine of x. If like if you're driving all the way to Disney World in Orlando and you get to the edge of the Texas border. We're almost there, guys. We've made it through Texas. We just got like 4 more states to go through. Right, and a whole bunch of trees. Yeah. All right, so good. I'm not messing with the cosine x sine of x in the bottom. Are you? I'm not. Are you? I hope not. So really all I have left to show is that everything else that's not highlighted on both sides is equal. Yeah, I know. Take a yawn. That oxygenates your brain. Maybe take a snack in the middle of this one. Right? Huh? 50 minutes. Enough. You'll have to practice enough coming in so that you're efficient. I probably wouldn't give you one quite like this on the test, to be honest, right? I mean, it would be one problem. Okay. Now, look at this. What is cosine squared, negative cosine squared minus sine squared? Is that anything? Is that 1? It's negative 1. Good. Because if you factored out the negative of both terms, you'd have negative 1 times the quantity, cosine squared plus sine squared. And what's cosine squared plus sine squared? Negative 1. So let me go ahead and just write this then as cosine x sine of x. And then I know that that's going to be 2 sine x cosine x minus 1. So that's like Papa Pid. If they're both negative, you can call it negative 1. Yes, great. Looking fantastic. Now what? I like that. Help me, anyone? Do what? Oh, you want to? Yeah, no, well, let's work on this. That cosine to the 4th is kind of bothering me a little bit. Is it bothering you? Yeah, because he doesn't have a sine in him, and that's what's ruining it. So let's go ahead and do what we did yesterday. We called that cosine squared squared. So let's go ahead and write everything down. Sine cubed of x, cosine of x, minus sine to the 4th of x, plus sine of x, cosine cubed of x, and then minus, I'm going to call that cosine squared squared, but I'm going to call it minus the quantity squared, and then cosine squared is 1 minus sine squared. So see what I did there? Y'all see that? That's kind of a double substitution. Cosine squared is 1 minus sine squared, but then it's still squared. That gives me something to work with now, because now I have some obvious math to do right there. Here, I'll show you off to the side. I said cosine to the 4th was cosine squared squared, and then cosine squared is 1 minus sine squared squared. So I'm okay. I can follow you if you do that. So let's do the obvious math. And we still have to be very, very careful because there's a minus sign. So because it is so much to copy and paste instead of write, we're going to do it in one line, okay? And y'all are going to help me. So we're going to square, multiply, double square, and then at the same time we're going to distribute a negative. So here we go. 1 squared is 1. Yeah, multiply, you get negative sine squared. Double, you get negative 2 sine squared. But negative 2 times the negative up front makes it positive 2 sine squared. Sweet. And then negative sine squared times negative sine squared is positive sine to the 4th. Times the negative at out front makes it negative sine to the 4th of x. Yes. Yes. Yo, I was hoping things would cancel. Oh, but they don't. But now I have 2 of these. We can make it an 8. No. You know. Man. All right. Maybe that took us away from where we wanted to be, actually. Maybe not. Are you okay with it still? No? Not at all? Okay, yeah. Is anyone else still following? We have to persist. Do we have time? We only have 7 minutes left. What can I do? Factor out, do I have a I have a -1 now that's ruining it. He don't got no sign in him. Show him the sign. Hey, let's just take a step back and say, we're almost there. We got cosine. Okay, good. It's just, yeah, optimism, right? So that, yeah, okay, so good. So that helps. That helps. Would you like to go back to the beginning and put it in terms of sine and cosine? Could we abandon it? It might have been at this point you're like, yeah, it doesn't factor. So, all right, I'm going to do it. We have time. I'm not surrendering. I'm just like, I'm 5 days down one path, and I'm realizing that this is not the right path. So I got to trek back 5 days, get back to the fork, and try another method. So I'm just going to put that over there. All right, so now we get back to the fork on the road, and we're like, okay, maybe we'll put a sign to the others, like, I don't know, don't go that way. Right. If you're looking for a 5-mile out and back, go that way. If you're not, okay, so, and we could probably still salvage it. Let's do this, okay, so this was Brooke's idea, and Brooke just maybe had tremendous insights from the very beginning. Plus cosine of x, it's good, it's okay. We're here for each other. We're together. That's what matters. We're together, and we're having fun. Yay! Oops. Yeah, see. Maybe I'm not your best guide, your leader. All right, so now we've created a complex fraction. Hooray. Now what's the LCM? It's just cosine sine. Right, instead of sine squared, cosine squared. So there you go. We're working with smaller powers now. The fact that we had fourth powers kind of made it difficult. So a little bit. Well, you would all come up with that same idea eventually, right? Some people just do things differently from the beginning. So anyway, you distribute now, and your cosines divide out, and you're left with sine squared. Plus, you distribute to the second one, and your sines divide out, and you're left with cosine squared. I'm already like, yeah. Man, don't that look good? And on the bottom, now if I distribute, I get cosine x sine of x, minus your sines divide out, and you're left with cosine squared of x, plus hang on. I'm doing something really violating laws here. I still have two terms. So when I distribute to the first term, the cosine divide out, I'm left with sine squared. So that's just my first term. I can't put the cosine squared up there. You got to be careful. That was my fault. Plus, now we do it over here, and now the sines divide out, and we're left with cosine squared, but the denominator is different. It's cosine x sine of x, and now it's going to be minus sine squared. So do we have a common denominator? No, we can't. We can't call that 1. So it's not a common denominator. But we can get a common denominator, right? Because our right side is already in terms of one term. So let's go ahead and factor now. We got sine squared. If we factor out a cosine, we're left with sine of x minus 1, or minus cosine, sorry. Sine minus cosine. And now I'm feeling the crunch of the clock, plus cosine squared all over, if I factor out a sine of x, I'm left with cosine x minus sine of x. All right, now I can get a common denominator. What's the common denominator? Well, I need a sine of x, I need a cosine of x, and isn't sine minus cosine just the opposite of cosine minus sine? Yes, so here's what I'm going to do. On that line, I'm just going to factor out a negative, and now you can call cosine minus sine, sine minus cosine. Okay, so that's all I did on that line, just to make him look similar. You don't want to introduce more information, because then you have higher powers, right? So now the LCM is just sine minus cosine times cosine sine. So all I need to do is multiply this one by cosine x over cosine x, multiply this one by sine x over sine x, and now I'll have my common denominator. And we're rounding third, heading home. Sine cubed minus cosine cubed is now your numerator. All over the denominator is sine x, cosine x, times sine of x minus cosine x. Now, in the top, we can factor that. That is a difference of two cubes. So remember, we just saw that. That's sine x minus cosine of x times sine squared plus sine x cosine x, and then plus cosine squared all over this. Sine x cosine x times sine x minus cosine of x. What happens now? Good stuff. That divides out. And what's sine squared plus cosine squared? 1. So I get 1 plus sine x cosine of x all over sine x cosine x. And is that the same as the right side? No! I have to commute the terms. I got to commute the terms and the factors. So it's cosine x sine of x by the commutative property of multiplication plus 1 by the commutative property of addition all over cosine x sine of x. And it's like, grrr. And that's us talking to the bear. Grrr, bear. We got you. And we got it right in time. The bell's not going to ring, okay? So there you go. Sometimes it's called sunk cost theory. At some point, you have to abandon a certain route and get yourself onto something different, all right? We're going to make the worksheet due on Monday. Oh, my gosh, thank you. You're so welcome, all right? Be ready for a quiz tomorrow. Have a great day.